Imagine this. You're sitting in a quiet village. Suddenly, the ground begins to tremble. Then, the peak of a mountain splits open and a coil of fire shoots into the sky. Rock, ash, and molten lava all come rushing down from above, all at once. This isn't a scene from a movie. It has happened again and again across the face of our planet. And even right now, somewhere on Earth, a volcano is stirring back to life. But here's the question. What lies beneath the ground that can suddenly explode like this? How does a mountain breathe fire? In today's episode, we're heading to one of the deepest, hottest, and most mysterious places on Earth, the birthplace of a volcano. So let's begin this journey, starting just beneath the surface of the Earth. The ground we stand on is really just a thin shell covering our planet. It's called the crust. This layer is so thin that if we compared Earth to an apple, the crust would be no thicker than the apple's skin. Beneath this skin lies the mantle, a massive, dense layer where temperatures are so extreme that even rock exists in a semi-molten state. And deeper still lies the core, the center of the Earth where temperatures rival the surface of the sun. Now, here's something interesting. The crust isn't one solid shell. It's broken into pieces called tectonic plates. Earth has roughly 15 to 20 major and minor plates, and they're constantly moving, incredibly slowly, just a few centimeters a year, about the same speed your fingernails grow. But this slow, almost imperceptible movement is actually behind some of the planet's most dramatic events: earthquakes, mountain formation, and yes, volcanoes. Because wherever two plates meet, collide, or pull apart, that's exactly where a volcano is born.
Now, let's get to the most important question. Where does this molten rock, the lava, actually come from? Deep underground, near the boundary between the crust and the mantle, rock melts into liquid form. This is called magma. But first, let's clear up a common misconception. Many people assume the entire interior of the Earth is filled with liquid lava. That's not actually true. So how does magma actually form? There are three main reasons. First, heat. In certain places, underground temperatures rise so high that rock begins to melt directly. Second, a change in pressure. Deep underground, immense pressure keeps rock solid even at extremely high temperatures. But when that pressure suddenly drops, for example through a crack in the plates, the rock melts into magma. This process is called decompression melting. Third, the mixing of water and other elements.
When one plate slides beneath another, the water trapped within it mixes into the mantle rock. And here's the interesting part. Water lowers the melting point of rock, much like salt makes ice melt faster. Once magma forms, it becomes lighter than the solid rock around it. And lighter things always rise, just like air bubbles rising through water. This magma then begins its journey upward, seeking out cracks and weak points in the crust. And if, at the end of that journey, the magma manages to reach the surface, that's the moment a volcano is born.
Now, here's a question. Volcanoes don't exist everywhere on Earth. So why do they form only in certain places? The answer lies at the boundaries of tectonic plates. Volcanoes are born mainly under three different conditions. The first way, where two plates are pulling apart from each other. This is called a divergent boundary. As the plates separate, magma rises up through the gap between them, much like water seeping through a crack in a wall. This is how the underwater volcanic chain of the mid-Atlantic ridge formed. Iceland is a living example of this process. Two plates are literally drifting apart there, which is exactly why the country has so many volcanoes. The second way, where two plates move toward each other and collide, this is called a convergent boundary. Here, a heavier oceanic plate usually slides beneath a lighter one, a process called subduction. As the plate sinks downward, intense heat combined with water produces magma, which then pushes its way up through the plate above. The famous ring of fire that circles the Pacific Ocean, Japan, Indonesia, the Philippines, the Andes of South America. This entire region is the result of subduction. Roughly 75% of the world's active volcanoes are located within this single ring. And the third way is a little different, a little more mysterious. Some volcanoes aren't found at any plate boundary at all. They sit right in the middle of a plate, deep in its interior. So how do these form? The answer lies in something called a hotspot. Deep within the Earth, near the base of the mantle, an unusually hot column of rock forms in certain fixed locations. This is called a mantle plume. This hot column stays completely stationary, while the plate above it slowly drifts. Over time, this creates a chain of volcanoes, one after another, like a line drawn across the ocean.
The Hawaiian Islands are the finest example of this, as the Pacific Plate has drifted over a fixed hotspot for millions of years. One island after another has been born. So, in simple terms, when plates pull apart, when they crash into each other, or when a fixed column of heat sits beneath them, any one of these three causes can give birth to a volcano.
Now, something here probably has you wondering. In Hawaii, lava flows almost like a gentle river. People can stand close and watch it. But in Indonesia or Japan, volcanoes can suddenly explode with tremendous force, killing thousands. What's the difference? The answer lies in the thickness of the magma and how much gas it holds. Hotspot volcanoes, like Hawaii's, produce magma that's relatively thin, fluid, and low in viscosity. Gas escapes easily from this kind of magma, much like slowly twisting open the cap of a soda bottle. That's why this lava flows calmly, without exploding. But the magma of subduction zone volcanoes is completely different. It's much thicker, stickier, and traps enormous amounts of gas and water vapor inside it. This thick magma can't release its gas easily, so pressure keeps building underground. It's like shaking a soda bottle violently and then suddenly popping the cap. Everything that was trapped inside comes rushing out all at once. Eruptions like this can send ash, rock fragments, and toxic gases several kilometers into the sky. So, put simply, a volcano's temperament depends on how thick its underlying magma is and how much gas is trapped inside it.
History holds some volcanic eruptions so powerful they remain etched into human memory forever. In 79 AD, Mount Vesuvius in Italy suddenly awoke. Within a single day, the entire city of Pompeii was buried under ash and molten rock. Thousands of years later, when archaeologists excavated the site, they found something haunting. People frozen in their final moments, cast in ash like sculptures. Then, in 1883, the eruption of Krakatoa in Indonesia produced a sound so powerful it was heard nearly 4,800 kilometers away. These events remind us, no matter how proud we are of modern technology, humanity still remains largely powerless before the forces churning beneath the Earth.
This very same process helped make our planet habitable in the first place. The gases released by volcanoes helped form Earth's ancient atmosphere and oceans. Volcanic ash makes soil incredibly fertile, which is why millions of people live in volcano-prone regions like Indonesia and Japan, because that soil produces richer harvests than almost anywhere else on Earth. So a volcano is, at once, both destroyer and creator. The very same force that can erase a city has also been giving birth to new life for thousands of years. And here's the most astonishing part. Right now, as you're watching this video, somewhere beneath the Earth, a new magma chamber is forming. Perhaps 1,000 years from now, a new island will rise from the ocean, just as Hawaii once did. The Earth never truly stops. Beneath its surface, a silent fire is always burning, one that sometimes builds cities and sometimes erases them. Is there a volcano near where you live or somewhere you know? Let us know in the comments. And if you enjoyed this journey, don't forget to subscribe, because the mysteries beneath our planet don't end here. There are many more stories to come. See you in the next episode.